Okay, YouTube, this is my last video in this mini module on sum and difference formulas. And in this video, I kind of like this one the best because it should be the shortest here. With respect to what we're doing, we're basically going to look at how we could use sum and difference formulas to rewrite an expression. So simplify this expression that you see here, like cosine of x minus pi. And it's pretty straightforward. We're just going to rewrite this using sum and difference formulas and take a look at what we get. And then talk about maybe what the implications of something like that would be, that process. So let's go ahead and take a look at cosine of x minus pi. If we're asked to simplify this, we'll automatically, hopefully, notice that this is a sum or a difference of angles here. And so because this is like our A angle here and this is our B angle, we can go ahead and rewrite this in that sum and difference form, noticing that because it starts with the cosine on the left, it must start with the cosine on the right, and that cosine does not alternate. That is, we get cosine of A, cosine of B, and its sign does alternate here, so we get a positive over here, a sum over here, since this is a difference. We have cosine A, cosine B, and then we'll get sine A, sine B. And so we're just going to drop in our angles here. It's just that with respect to A and B this time we have an X is our first angle here. So we have an X, and then we also have a pi and a pi. So a pi and a pi. And so the neat thing about this is, well, first of all, we could find the cosine and the sine of pi just by looking at our unit circle. As a matter of fact, pi is a quadrantal angle. That is this angle that rotates all the way over to here. And so with respect to what we get on the unit circle for the cosine and the sine respectively, we get -1 and 0. So looking at what we have here, we have the cosine of x times the cosine of pi. Now I can't tell you what the cosine of x is. I don't know. I mean, I don't know what x is. I suppose it would depend upon x. But the cosine of pi I can tell you is -1. And so for instance here, what we get is the cosine of x times the cosine of pi, which is -1, and then over here we're going to get the sine of x, which again, is arbitrary depending upon what x is, and the sine of pi, which is, well, the sine of pi is 0, and so I'm going to drop that in there. The neat thing about this is, the product of anything in 0 is just 0, and the sum of anything in 0 is itself, and the product of anything in -1 is the opposite of itself. We really just get the negative cosine of x, and so it is true to say that, 100% of the time, if you were to take cosine of an angle and subtract off, say, 180 degrees or pi radians, you'll just get negative the cosine of what this initial angle is right here. But that being said, essentially what I want you to understand is that this may come in handy when you're solving equations. It may be the case that you want to rewrite an angle as a single angle, and that might be helpful. Or maybe if you're integrating or differentiating, if you're in a calculus class, or maybe we just want to verify an identity and say, I want to prove the left side equals the right side, and so it's necessary for us to rewrite it from this form into this form using sum and difference formulas. So another good use for sum and difference formulas is to rewrite expressions into alternate forms that might be more helpful given the circumstances. Cheers.